All right. Hi, guys. This is Mr. Crowfoot, and I'm here to talk to you about the Coriolis effect. And at this point, you should have done the warm up, which is right here. And if you haven't done the warm up yet, please take a moment, do that, pause the video, and then come back. So, for all of you that have done the warm up, though, let's go ahead and talk about it here. It says that you should think about the lesson on Hadley cells, which is to talk about uh, these guys right here. And for each location indicate the direction the wind would blowing on the surface. Okay, so like imagine that you're standing right here. What direction is the wind blowing, north or south, as a result of the Hadley cells there? So if you can't see it, I know it's a little bit, we're zoomed out a bit. Let's see if we can zoom in a little. All right, we can see that the wind would be blowing south right there, right? You can see this little arrow right there. So if you were standing, on the surface right there, the wind would be blowing to the south. So let's see here. So that's because, right, for 15 degrees, which would be halfway between 0 and 30, means you're right in there. That would be going south, going south. If you're standing right here, right, then the wind would be blowing north. If you're standing at 45 degrees, so 45 degrees north would be right here. There you are. The wind is blowing to the north. And lastly, if you're down here at 45 degrees south, halfway between 30 and 65, just draw another little guy there, right, the wind would be going to the south. So there you go. So those are the answers to the warm-up, and looking at the Hadley cells, you can figure out what direction the wind would be going on the surface. So the next thing that we want to do is we want to take a look at, like, is that actually what happens? So when we look at the weather data, does the wind blow directly north or south at those locations? So let's toggle over and take a look at this map right here. And this map right here shows the wind directions at any given time. Or actually, I don't know when it's from, but these would be the general wind directions. And so you can see the little guys moving there, showing us the wind directions. And when we look at that, what we note is that we do not see winds going directly north and directly south, right? They have some east-west part as well. So if we take a look, here's our equator right here, this line. So our Hadley cells would be kind of in this region right here. We would expect them to be blowing south at 15 degrees. So they are blowing south, but they're also blowing to the west. And when we look down here, we would expect these to be blowing to the north. Given the warm-up we just completed, we expect them to be going north, and they are going north, but they're also going to the west. And so as we look at this data here, and just, it's not this particular area, by the way, like I can toggle over to here, and we see that very same pattern in this area, right? The wind is going to the north and to the west. So we would expect it to go to the north. The west is kind of interesting. Same thing right here. We would expect the wind is going to the south, and also to the west. We expect it to be going to the south. The west is kind of an interesting point on that. So why is that the case? So this east-west movement of the wind is caused by something called the Coriolis effect. So let's move over and take a look at a globe to better understand why that happens. All right, so here we go. Now we got our globe. And as we look at it, here's the equator right here. And our Earth is going to be spinning this direction. And so I've gone ahead and put two little pieces of paper on here so that I can draw on the globe. And so if we take a look at them, we know that in this area, right, between the equator and 30 degrees north, we know that the air is traveling to the south because of the Hadley cells, right, from our warm-up. So if I take a marker and I draw an arrow to the south, and I'm going to run my arrow straight up and down, so right, I'm just going to move it right along this little bar right here. And as I do so, I'm going to go ahead and turn the Earth as though it's spinning, just like it actually does, right? So here we go. I'm going to turn the Earth. And sorry, having some issues there, but right, we get that sort of a line. So as you take a look at that, right, you can see that we're getting kind of a curved line there. We'll go ahead and do the same thing with the southern hemisphere. Hang on, let me turn it around here, and all right, we'll draw the same line. Keep in mind that in this, right, in the bottom part down here, the air is traveling to the north. So I'm going to start down low down here, and I'm going to move my line straight up as I go, trying to turn it. And so, right, we see that we get a line, right, that is kind of up and to the left here. So, give me 1 second here. All right, so I went ahead and peeled them off the globe so that we could look at them here. And so let's remember that when I was drawing this for the southern hemisphere, remember that I was trying to mimic the Hadley cells, and the Hadley cells go north in the southern hemisphere. And so, right, I was trying to draw a line straight up, right? So what we see is that when I try to draw a line straight up, it gets curved to the left. Right there, you can see it gets curved to the left. So it was, right, because I moved my marker straight up, and the line ended up going up and to the left. So the northern hemisphere one is a little bit harder to understand, right? Because it looks like it's also going to the left. However, keep in mind that I was drawing my arrow straight down, as though something was moving straight down. So I actually have to flip this over to think about the direction that it goes. I was going in this direction, but then it curved and went that direction, so it actually curves to the right. So the Coriolis effect makes things in the northern hemisphere, right? The northern hemisphere, it makes them curved to the right, and it makes things in the southern hemisphere curve to the left. So hopefully that makes sense. Now, this particular way of kind of demonstrating this works really well if you have something that is traveling away from the poles towards the equator. So the demonstration that I did right there was able to show us this, and it works really well for thinking about how the Coriolis affects things that are going away from or going towards the poles. This same phenomenon, this left and the right, also works if you're going towards the poles, but the demonstration doesn't work in that case. So the demonstration only works to kind of initiate this right and left business. The right and left holds true for any motion, any straight line motion on the Earth. But the way of thinking about it doesn't work if you're going where we draw a line like that. It doesn't work if you're going towards the poles. That doesn't work. So anyway, thank you. Well, now we're going to head back to our assignment and fill a couple more things out. Thanks. All right, so the next part is to take and apply what we've learned. So recall that what we just learned was that things in the northern hemisphere curve to the right. So on your assignment, so now if you have ability to print this, you should go ahead and print this. If you can't print this, then just follow along and record your answers on a piece of notebook paper. So we'll go ahead and do that. So for number one, right, in the northern hemisphere, the Coriolis effect causes things to bend to the right. That's not what I just said. Yeah, to the right. And in the southern hemisphere, it causes it to curve to the left. So if you don't have, if you can't print this paper, just write those two sentences out in your journal or something like that. Then, or you can actually just type it in there. The next part you will have to do in your journal. So, right, so it has basically these arrows here. We'll just quickly kind of copy this. If you didn't, right, if you don't have, and right, so in the northern hemisphere, it's going to cause things to curve to the right. So that means that this is going to end up getting curved to the right, something like that. And here's the tricky part, right? If it's down, if it's pointed down, it's best to just flip your paper over and then curve it to the right, like so. Right, southern hemisphere. That's going to do the opposite. That curves to the left. So in this case, it would curve to the left, like so. And this one, again, best to turn your paper upside down and curve it to the left, like so. So there we go. That's that part done. So moving on to the next part, it says if you can print it out, then do that. If you can't, then we're going to need to copy this onto our own paper. So kind of as before, find something that is circular that you can kind of trace yourself a nice circle. So I'm going to go ahead and I'm going to use this lid here to make my circle. Maybe it would have been nice to have something a little bit bigger, but that's what I got. And then I'm going to go ahead and put in the 0, 30, 60, and 90 that's on there. So I got my 0, so it should be 30 south, 60 degrees south, 90 is of course down here, and 90 and 30 degrees north. So so now I've pretty much kind of copied this drawing right there. So we got that. So the first thing it says is using a pencil, lightly draw the direction of the Hadley cells to make the wind blow. So again, this should probably be done in your journal. And so we know that the Hadley cells are going to be going, right? We did this in the warm-up. We know that they're going to be going south in this direct region, north in this region. This is stuff from, I'm just drawing the arrows from the warm-up that we just did, right? North in this region, south in this region, north, and this would be south. You'd have to look at the drawings. We didn't talk about the polar cells, which would be these guys and these guys, but if you look at the diagram, it should be pretty clear. So now I just need to go ahead and apply, right, the second thing. It says, now draw darker lines showing how the wind would blow or bend as a result of the Coriolis effect. So now take use your pencil, but draw darker. But we want to go ahead and apply the Coriolis effect. So remember, this thing's down here, curve to the left, things up here, curve to the right. So for the ones that are pointing up, that's really easy. I'm going to curve these to the left. Right, these curve to the left as well. These up here, let's see here. Oh, before I get to that, let me finish with the lower ones here. Got to turn my paper upside down. These ones are also going to curve to the left. Okay, so there we go. Got the southern hemisphere taken care of. Now I got to do the northern hemisphere. Northern hemisphere goes to the right, so they're going to curve that way. Better turn my paper upside down for these guys. They're going to curve to the right. And these ones go to the right as well. So there we go. There's your map for the Coriolis effect. So there we have that part done. So what you got to do now is you have a series of questions that you're going to need to answer. So you have, starting with this one here, hundreds of years ago, talking about ships. Then the next page, right, and you can just type that in to the document that you're going to go ahead and submit. So when you go to submit your answers, you will take a picture of your journal if you ended up doing them in your journal. Obviously, if you did it on here, just take a picture of that. And then you'll probably just type your answers for this. You could just, if you can print it, you could just handwrite it. But if you, if you just take a picture of the drawings and attach those to Canvas, as well as upload the document with your typed answers in this here, and your typed answers to page 3, which would be this right here. You should find it goes right along with the notes, shouldn't be too terribly difficult. Before you take a picture of your drawing, please make sure you do number 5 here and number 5 here. It has you label the wind directions, and we'll be looking for that when we look at your drawing, that you're gonna have you know, like the northeast trades and the westerlies and the polar easterlies written on here, labeled on here. So just make sure that you've done that before you turn it in, because that's a part that a lot of people forget. So, all right. Well, thank you for watching, and I hope that kind of made some sense. And yeah, have a good day.